condition that must be avoided is that of overspeed, and this could occur in the case of a load rejection, for example. Similarly, we would get the same result if the generator breaker was tripped open by mistake when the unit was loaded to about 50% capacity. Of course, the turbine generator would immediately increase speed because at the instant of the breaker trip, a very large quantity of steam is flowing through the turbine. Under normal circumstances, the governor should be able to close the turbine control valve sufficiently to bring the speed close to normal within a few seconds. However, imagine what would happen if the governor failed to act properly, or the power piston seized, or some other defect prevented movement of the control valves. In this case, steam flow to the turbine would continue, with the result that the speed would rapidly rise to 2 or 3 times normal. In practice, the speed would not get that far, because centrifugal force acting on the mechanical parts of the turbine and generator rotor would cause them to break up. Several instances have been reported of turbine blades and sectors of turbine wheels passing right through the turbine shell into the turbine room, with the potential for injury to plant staff and damage to other equipment. In order to prevent this possibility, 1 and sometimes 2 quite separate overspeed protection devices are installed and set to operate at 10% and 12% overspeed. Each protection device operates a trip relay to close the stop valve and other protective action, as already discussed. Here we see an example of a traditional mechanical overspeed device. Essentially, it consists of a bolt inserted into the shaft. As the shaft rotates, the bolt tries to fly out by centrifugal force, but this is restrained by a compression spring. The spring is carefully adjusted so that the centrifugal force does overcome the spring compression at 10% overspeed. The bolt then mechanically trips the latch, which allows the trip relay to move to the trip position, so draining off hydraulic oil and closing the stop valve. You will remember that tripping the stop valve also actuates the positive closure of non-return valves on the extraction lines. This is necessary to prevent entrained steam being drawn back into the turbine and aggravating the overspeed condition. Another common type of overspeed relay uses electrical measurement of speed and an electrical circuit to initiate operation of the trip relay through a solenoid. It is vital that these overspeed trips be checked for operation at regular intervals and the actual tripping speed be recorded. Now, this may be done when the unit is being shut down or started up. Adjustment of the setting may have to be made from time to time. This protection device is one of the most important on the turbine.